about the steps above, let's just talk about logically where would you go with this. So when we write a piecewise function, it gives us our lines, and then it gives us what's called like a domain restriction. Domain, we're talking about our input values. We're talking about our x values typically when you're talking about domain. So the restriction is this function we only use if x is less than 2. Does that make sense? And then this function, this piece of our function, we'll use if x is greater than 2 or equal to 2. Okay? So if we have x equals 0, where does that fall? Is 0 less than 2, or is it greater than 2? It's less than 2. So for x, or f of 0, my function when x is 0, which equation would I use? X plus 2. Okay. So conclusion over here, if I plug in 0, 0 plus 2 gives me 2. So my function when x is 0 equals 2. Okay, function notation, I really like for you to rewrite it at the end. So f of x means my function for a specific x value. My function when x is 0 equals 2. By writing your answer like this, you're essentially giving an ordered pair in your solution. So instead of just giving like y equals 2, you're saying x is 0, my y value is 2. Okay, f of x and y are kind of interchangeable. So when I look at my answer, I have both values. This is my input, that's my output. This is my x value, that's my y. Input, output. This is my input. This is my output. Put in 0, I get out 2. So, f of 2. So if my function is 2, which equation should I use?
2x plus 1.
Yeah, because I use 2x plus 1 if x is greater than or equal to 2. So I would use the 2x plus 1. So my function, when x is 2, would be 2 times 2 plus 1. Or 4 plus 1, which is anyone? 5 things. So my function, when x is 2, is 5. My x value is 2, my y value is 5, if I were to plot that point on a graph, okay? Input is 2, I get out a 5. 2, 5 would be the ordered pair. What about if it said f of 4? Evaluate your function when x is 4. Which equation would I use?
2x plus 1.
2x plus 1, because 4 is greater than 2. So my function when x is 4 equals 2 times 4 plus 1. Sorry, it's driving me crazy. What's 2 times 4?
8.
And 8 plus 1 is? 9. Great. So if I put in a 4, I will get out a 9. X is 4, y is 9. I don't even know if I'm going to fill in anything up above right now. Does that kind of seem just like a logical approach to this, right? You have to find the equation that makes sense. The evaluating these should be the easiest part of the unit. Okay? Let's flip this over. So here's another piecewise function. My function is 5x subtract 1 if x is less than negative 2. And I'll use x subtract 9 if x is greater than or equal to negative 2. So for the first one, where I have negative 4, which piece will I use? Yeah, because negative 4 is less than negative 2. So I'll use the 5x minus 1. That's the equation I'm using. So if I use that here, I get 5, and where x is, I'll plug in my input value of negative 4. What's 5 times negative 4?
Negative 20.
So I get negative 20 minus 1, or my function when x is negative 4 equals negative 21. Again, that's how your answer should look. You should have that function notation, this guy right here, still as part of your answer. It tells me if x is -4, y, or my output, is -21.
So the output's always Y?
Yeah, pretty
So
much.
it's like with the,
Unless you have like
y
random
intercept?
variables like t and, but yeah, x and y. X is typically your input, you put in an x value, you get out a y value. F of -2, which equation would I use?
X minus 9.
Because if x is greater than or equal to -2, I use x minus 9. So, plugging in -2 where I see x, I get -2, subtract 9. So my function, when x is -2, equals -11. My x value is -2, my y value, or my output, is -11. What about when x is 0?
X minus 11.
What?
X minus 11.
X minus 9?
I mean, yeah.
Yeah. So if
My
x
bad.
is 0, if I go up here, I use x minus 9 if it's greater than -2. Well, 0 is greater than -2, so I'm going to use x minus 9. If I plug in 0, 0 minus 9 would give me -9. F of 0 is -9. What about f of 5? X minus 9 again. So I would plug in 5 minus 9. F of 5 would equal